In this module, we will conclude the surveying of our path and calculate the error within our survey. In modules 1, 2, and 3, we introduced the equipment, began the survey, and moved our level locations using a turning point. The survey employed a second turning point so that we could have a third level location, and stations were measured up to the end of the path, which is where we are now. The level is now located in the third location, and we wish to complete the survey. First, we will survey the last location on the path, and then the closing benchmark. The final location on our path is measured. The station location is 2 plus 80 meters, and we will now take the reading here. Note that this is not a turning point or benchmark, so the reading is still entered in the intermediate site column in our lab book. Let's enter the last point on our path, and calculate the elevation at the end of our path. To close our survey, we need to finish the surveying by taking a reading at a benchmark. Since there is a benchmark at both the end and the start of our path, we can end at benchmark 2. If there was no benchmark at the end of our path, we would need to conclude our survey with a reading at benchmark 1. Since benchmark 1 is a large distance away, we would need to employ even more turning points in order to even see it. With the rod person on benchmark 2, we take a reading at the benchmark. Since this is a benchmark, the reading must be entered in either the backsight or foresight columns. Since we are looking forwards towards the end of the path, this is a foresight. With this foresight, we calculate what the elevation of the benchmark is. After the elevation of the benchmark has been calculated, we then compare it with the known elevation of the benchmark to determine what the error in our survey was. In this case, the known elevation of the benchmark is 97.949 meters. Since our observed elevation was 97.929 meters, then our error in our survey was 20 millimeters. To determine whether this is acceptable, we look at the requirements for the survey. This survey had requirements of a fourth order survey, which has an error tolerance of plus or minus 120 times the square root of k millimeters, where k is the length of our survey in kilometers. In this case, our survey was 280 meters, or 0.28 kilometers long. Plus or minus 120 times the square root of 0.28 gives us plus or minus 63 millimeters. Since our error of 20 millimeters is less than 63 millimeters, our survey meets the fourth order requirement and is acceptable. The survey can now be corrected using methods shown in class to complete the survey work.